Good evening, everybody, and welcome back. We're going to talk about the theory of production, and you will find that in your textbook in chapter number 9. Chapter number 9 will also cover the cost of production, which we will get into later on. This evening, I will be flipping back and forth between the PowerPoint presentation and a graph, so hopefully everything will go smoothly. So the production function of any commodity is an equation, table, or graph showing the maximum quantity of the commodity that can be produced per unit of time for each of a set of alternative inputs. And please highlight this, what is in red. It is very important that we use the best production techniques available. If we're not using the best production techniques, somebody will eat our lunch, put us out of business. So the production function is the relationship between the firm's inputs and outputs of the goods and services that they produce. An example of a function can take the following form. The quantity of output depends upon the quantity and quality of the labor that we have employed, and also the quantities of a fixed quantity of land. We're going to go through an agricultural problem here, but it doesn't matter if we're in a factory or in a hotel or something along that nature. So a simple agricultural production function is obtained by using the alternative quantities of labor per unit of time to farm a fixed amount of land and recording the resulting alternative outputs of the commodities per unit of time. Please highlight what is in red, and this is extremely important that we are referring to, in this case, that we're using at least one factor of production or input that is fixed. In our example, land is fixed. The farmer has a certain number of acres. That is fixed, that cannot be changed. And as soon as you have one fixed factor of production, we are in the short run. That is extremely important to realize. So the average product of labor is then defined as the total product divided by the number of labor used. So the APL, the average product of labor, is equal to the total product, TP, divided by L labor. That's the first equation that you're going to have to be working with. The marginal product of labor, the MPL, is given by the change in total product per change in the quantity of labor used. So your MPL is equal to the change in total product divided by the change in labor, which then equals to total product 2 minus total product 1 divided by labor 2 less labor 1. And it's the marginal product, so once again, it'll be recorded in the middle. Very important that it is always recorded in the middle, on the table and also on the graph. So the table below gives us the short run production function of wheat that this farmer will be growing. Land is measured in acres, labor in worker years, and total product in kilograms produced per year. All unit of land, labor, or wheat are assumed to be homogeneous or the same quality. This is a simplification of reality. What homogeneous means is that every person is as productive as the next. It's a simplification of the problem. It's not reality, but it makes the arithmetic easy. It's also that each square meter of land is as fertile as the next square meter of land. It yields the same amount of wheat, which is again a hypothetical situation, but it makes the arithmetic fairly easy. So on this, obtain the average product of labor in column 4 in this table and obtain the marginal product in column number 5. So here is our table. We're asking you to calculate the average product of labor, and the average product of labor is going to be the total output divided by labor, and the marginal change is going to be the change in total product divided by the change in labor, and it's going to be recorded in the middle. So we have here instructions. The average product of labor figure in column 4 are obtained by dividing each quantity in column 3 by the corresponding quantity in column number 2. And the marginal product of labor figures in column 5 are obtained by finding the difference between the successive quantities in column 3 and dividing through by the change in labor. Please highlight and remember, recorded midway between the quantities of labor used. So here's our table as it looks. The average product of labor, as indicated, is your total product divided by labor, and your marginal product of labor is the change in total product divided by the change in labor. So here it is, just 3 divided by 1, 8 divided by 2, and so forth. And your marginal product is the change in total product, 3 less 0, divided by the change in labor, 1 less 0, recorded in the middle at 0.5. So we get 3 over 1, which is equal to 3. The next one is going to be 8 less 3, divided by 2 less 1, recorded in the middle at 1.5. We're going to get 5 over 1, which will be equal to 5, and so forth. Once you have this, you're going to have to record it or plot it on a graph, a two-part graph. Please remember that a two-part graph has the y-axis aligned. They must align. The x-axis must have the same scale so that you can read and draw conclusions from it. I'm going to switch now. To the graphs. So here's the graph for that particular table. We have on the top, it's a two-part graph. Remember again that the y-axis has to align, and on the top one, we're going to put total product. On the bottom graph, we're going to put the average product of labor and the marginal product of labor. The scale on the x-axis, which is labor, will have the same scale, very important. We will plot the total product axis, or graph, I should say, and it is going to be increasing at a decreasing rate. It will top out, and after a certain point, the total output will fall. So that means that there's an ideal number of employees that a company should employ. If they have too little, they're not going to get the maximum output. And if they have too many employees, they're not going to get the maximum output either. On the bottom, we're going to plot our average product of labor curve and our marginal product of labor curve. You'll notice that when the marginal product of labor curve is starts off above the average product of labor curve, the marginal product curve reaches a maximum at point J very quickly, and then it starts to decline. That's indicated in your total product curve that it is increasing at a decreasing rate, as your numbers on the table will indicate. This graph at point J also indicates that the law of diminishing returns starts at point J. That means the total output is increasing, but it is increasing at a decreasing rate. This point right here, where the marginal product of labor curve intersects with the average product of labor curve, indicates where the average product of labor curve is at its maximum. And we'll talk about that point a little later on. The ideal number of employees that this company should employ is where the marginal product of labor is equal to zero. Once again, where the marginal product of labor is equal to zero corresponds to where the total product is at its maximum. This farmer should only have 5.5 employees. If they have less employees, their output is less. If they have a more than 5.5, their output is also less. This is where companies sometimes that are in a situation where they're working in this area right here where marginal product of labor is negative, that they will go through what is called a rationalization program. In other words, company will hire consultants to come in to figure out how many employees they should have. So if they're employing 8 employees, their total output is not at maximum. And you'll notice that as they reduce the number of employees, total output will increase. And at 5.5 is where the total output is at its maximum. So this company, in reality, will fluctuate somewhere between 5 and 6 employees, but 5.5 is the ideal number where productivity is at its highest. Now, there are many reasons why productivity isn't always at its maximum. It could be lighting factors. An example could be the poor lighting in some of the classrooms at Conestoga College. In factories, if some of you've been to factories, you've noticed that there are rubber mats on the floors to cushion the stress on the joints of the legs and things like that. Ergonomically designed knives would also increase productivity. And that's all indicated here by this theoretically best number of 5.5 employees. Now I'm going to switch back to the to the PowerPoint presentation, and we will continue from there. Keep this graph in mind. Hopefully you have a copy of this graph beside you. So So we're back again. So right here at where the marginal product of labor at 5.5 employees is zero, that tells us once again that that's the ideal number of employees that this company should have, 5.5. You will see that the marginal product labor curve rises very quickly. It goes from 3 to 5, and then it starts to decrease. This means that the total product is increasing at a decreasing rate. So you see it goes up to 3 to 8 to 12 to 15, 17. It maxes out at 17. If you have more employees, total output drops to 16. If you add even more employees, total output drops even further. So the ideal place for this company is at 5.5 employees where the marginal product is zero, your total product is at its maximum. So to recap, the total product and the average product of labor and the marginal product of labor schedules of the above are plotted on the graph that you just saw. Since the marginal product has been defined as the change in total product per unit change in the quantity of labor used, each value of the marginal product of labor has been recorded in panel B. Halfway between the quantities of labor used. Please, once again, if you have a hard copy, please highlight halfway in the middle. So the shape of the average and marginal product curves. The shape of the average product of labor and the marginal product of labor curves are determined by the shape of the corresponding total product curve. So if your total product curve changes its shape drastically, so will the average product and the marginal product of labor curves. Um, I'm going to switch back to the graphs for a moment. I'm going to ask you to do something. So please have a piece of paper and pencil ready. So back to these graphs. What I'd like you to do is I'd like you to draw a chord from the origin on the total product curve. I'd like you to draw a chord from the origin to point A. So from 0, 0 to point A, draw a chord and calculate the slope. Then I'd like you to do the same thing from the origin 0, 0 to point B, draw a chord and calculate the slope. Do the same thing from 0, 0 to point C and calculate the slope, and to point D, to point E, F, G, and H. I'll give you a few seconds and then we will talk about what you just did. Well, hopefully you noticed once you calculated the slope from the origin to a point on the curve, 0 to point A, 0, 0 to point B, 0, 0 to point C, and so forth, that the slope there is equal to the average product of labor. What you just did was you geometrically just determined the average product of labor curve by drawing a straight line from the origin 0, 0 to point A to point B to point C and so forth. That's the geometric calculation of the average product of labor. Now, if you were to calculate the slope between 2 points, the slope between 2 points is from the origin to point A, 0, 0 to point A, and then between point A and B, between point B and C, C and D, and so forth. I would recommend that you do this little exercise. It will solidify in your brain that way. So the slope between 2 points is actually calculating the marginal product of labor in this case, which once again is the geometric way of calculating the marginal product of labor. Very important points to remember. I think at least one question on the exercise will ask you to do that. So it's important. So hopefully from here on in, you could use that technique to calculate the average and the marginal for any curves that you will be working with. So I'm going to now switch back to the PowerPoint presentation. So the shape and average, the shape of the average and marginal product curves, the shape of the average product of labor and the marginal product labor curves are determined by the shape of the corresponding total product curve. The average product of labor at any point on the total product curve is given by the slope of the straight line from the origin to that point on the total product curve. Please highlight what's in blue. The marginal product between 2 points on the total product curve is equal to the slope of the total product curve between 2 points. The marginal product curve also rises first, reaches a maximum, and then declines. The marginal product of labor becomes 0 when the total product curve is maximum and negative when the total product curve begins to decline. The falling portion of the marginal product of labor curve illustrates the law of diminishing returns. Please highlight the last sentence. And here's the law of diminishing returns. As additional quantities of a variable factor are added to a given quantity of a fixed factor, after a point, the marginal product will diminish. What is the variable factor in our example? Well, hopefully you said to yourself, labor, and the fixed factor is the land. The land is fixed, it's the labor that will be changing. So the point of diminishing marginal productivity occurs at the level of output at which the marginal product is at a maximum. So the marginal product of labor in our example is highlighted by point J on the graph. That is where the law of diminishing returns starts. The, the law of diminishing returns states what will happen to physical returns rather than what happens to monetary returns. In other words, it talks about the output that the company produces, not about the money that it will receive from selling the output. So in the above diagram, or in the diagram of the graph, the average product at point A on the total product curve is equal to the slope of 0A. This is equal to 3 and is recorded as point A prime in the graphs that you have in panel B. The average product of labor at point B on the total product curve is equal to the slope of the dashed line 0B, and this is equal to 4 and is recorded at 4B in panel B. At point C, the average product of labor is again 4. This is the highest point on the APL. Past point C, the average product of labor declines, but remains positive as long as the total product is positive. The marginal product of labor between the origin and point A on the total product curve is equal to the slope of 0A. This slope is equal to 3 and is recorded halfway between 0 and 1 at 0.5 or a half in panel B. Please highlight what is in red. The marginal product of labor between A and B is equal to the slope of AB. This is equal to 5 and is recorded at 1.5 in panel B. The marginal product of labor between B and C is equal to the slope of BC. This is 4 and is equal to the highest APL, the slope of OB and OC. It's not O, sorry, the slope of 0B and 0C. Between E and F, the total product curve remains unchanged. Therefore, the marginal product is 0. Past point F, the total product curve begins to decline and the marginal product of labor becomes negative. The marginal product curve reaches a maximum before the average product of labor, that is point J. As long as the average product of curve is rising, the marginal product of labor is above it. When the average product of labor curve is falling, the marginal product curve is below it. When the average product of labor is maximum, the marginal product of labor is equal to the average product of labor. That is the point of intersection. So for the APL to rise, the addition to total product, the marginal product of labor, must be greater than the previous example. So the previous output. For the APL to fall, the addition to total product, the marginal product of labor, must be less than the previous average. And the third point, for the average product of labor to remain unchanged, the addition to total product, again, the marginal product of labor, must be equal to the previous average. So what does all of that mean? What does all of that mean? An example would be if I have a class of 25 students and 24 students write a test on the assigned date, and there's an average of, let's say, 70%. The 25th person writes the next day and scores 90. That means that the average product, the average score will go up. Bullet point number one. So same example for bullet point number two. I have a class of 25 students and 24 of them write on the appropriate day, score 70 as an average, and the 25th person writes and scores 40 the next day. That means that the average will fall. Same example again for bullet point number three, 24 write on the given day, the 20 and score an average of 70, and the 25th person writes the next day and scores 70. The average will stay the same. So highlight this on the graph that the law of diminishing returns starts operating at point J in panel B. This is where the marginal product of labor begins to decline. This occurs because too much labor is used to work 1 acre of land. If even more workers were used on 1 acre of land, these workers would start getting in each other's way until eventually the marginal product of labor becomes zero and then turns negative. So remember, where the marginal product of labor is equal to zero, and in our case it's 5.5 employees, that is the ideal number of employees that this farmer should have. So the law of diminishing returns, as additional quantities of a variable factor are added to a given quantity of a fixed factor, after a point, the marginal product will diminish. The point of diminishing marginal productivity occurs at the level of output at which the marginal product is at a maximum. Once again, that is point J. So in conclusion to this video, the law of diminishing returns states what will happen to physical returns rather than what happens to monetary returns. And hopefully we will see you on the next video. So see you in a second or two.